Hello, fam. This is Zazu from Entertainment, reminding you that enthusiasm implies excellence. Our lesson for today is still based on number pattern, but we will be doing arithmetic series. Okay. What is an arithmetic series? An arithmetic series is the sum of the terms in an arithmetic sequence with a definite number of terms. Okay. Here we are required to prove that sum of arithmetic series can be written as follow. In fact, Sn is equal to n over 2 all multiplied by 2a plus into n minus 1 times d. So let us prove this, guys. Okay, for you to prove this, you have to write sum of terms from your first term plus your second term plus your third term plus you can just add your last term here. Okay, so you start from your first term, you keep adding terms until you reach to your last term, and then we'll call this one your equation number 1. Let us have our equation number 2. Going to change the color for equation number 2. Our equation number 2 will be Sn is equal to, we start from the last term to the first term. So that one will be a plus into n minus 1 times d plus. So the term before this one has a plus into n minus 2 differences times d plus the term before this one will be a plus into n minus 3d plus a. This is the equation number 2. So let us add your equation number 1 plus your equation number 2. Right. So you have your Sn plus Sn, you end up having 2Sn equal to, okay, so this is your first term. So let me circle the part that you are adding, add this yes. So a plus a, it is 2a plus into n minus 1 times d. Now you add term number 2 from your first series, you add it with your term number 2 of your second series. Yes, so it becomes plus. So here you have your a plus a, you have 2a plus, you say n times d, dn minus 2d minus 2 times d, it's minus 2d, and then you plus d, you plus this d, close the bracket, then you say plus. So now let's just go to this one. Third term, you add it with your third term also. Yeah, okay. So you'll have your a plus a get 2a plus your n times d, that one is dn, your minus 3 times d, that one is your minus 3d, plus 2d, plus, now you add these two. Which color to use? Let me, okay, now you add these two. Yes, you add a last term for your first series and the last term for your for your second series. So a plus a, you have 2a plus n minus 1 times d. Okay, so here you have 2 Sn equal to a plus into n minus 1 times d, close the bracket, plus 2a, so plus dn minus 2d plus d, it becomes minus d, plus you have your 2a plus dn minus 3d plus 2d, you end up having minus d. Oh, I missed something here. There is this 3 dots plus. So between these two plus, there is this 3 dot, meaning there are terms before this term, before the last term, in fact. So here, okay, plus your 2a plus into n minus 1 times d. Yes. Moving forward. Okay, yes. Like this. Okay. So now you have 2Sn equal to your 2a plus into n minus 1 times d plus 2a plus, so here you see you have the common factor of which is d, so you take out the common factor, you are left with n minus 1, you multiply by d, plus 2a plus, you have a d as the common factor, so you take out d, you are left with n minus 1 times d, plus is 2a plus into n minus 1 times d. So you see here this is same as n times 2a plus into n minus 1 times d. Why am I saying this is same as n times 2a plus into n minus 1 times d? This is the repetition of the same, this is the repetition of the same term, because I call this one a term. So this term keep on repeating itself. So to avoid adding the very same term, you can just multiply that term with the number of terms that are there. So here we don't know the number of terms, that's why we just multiply it by n. So here it is your 2Sn. So you divide both sides by 2. Divide both sides by 2. Therefore, your Sn is equal to n over 2 into 2a plus into n minus 1 times d. Therefore, it is proven that an arithmetic series can be written as Sn is equal to n over 2a plus into n1 minus 1 times d. In addition, but we are done with what was required for us to prove this. But you can also write this as Sn is equal to n over 2, open bracket, say a plus l, where l is last term of which is a plus into n minus 1 times d. So you only use this if last term is given. So you can be required to solve this arithmetic series as this format or as this format. So if you are required to solve an arithmetic series as this format, that's where you have to indicate that you know that your L is equal to your last term, is equal to your last term. This is all for today. I'm looking forward to meet you next time. Thank you, guys.